The unexpected meaning of absolute zero. Absolute zero sounds like emptiness, total stillness, a complete stop, but physics hides a deeper truth there. To understand absolute zero, we must forget intuition. Cold feels like the absence of motion. Lower temperature means slower atoms. So zero should mean no motion at all. But reality refuses to freeze completely. Temperature measures average motion. As systems cool, motion decreases. Atoms vibrate less. Molecules slow. Order seems to increase. Yet something stubborn remains. In the 19th century, scientists pushed temperatures lower. Gases liquefied. Liquids solidified. Each step felt closer to stillness. But as limits approached, progress slowed. Cooling became harder. Nature resisted. This resistance was not technical. It was fundamental. Even with perfect insulation, perfect control, and infinite time, absolute zero remained unreachable. Something prevented motion from vanishing. Quantum mechanics revealed why. Particles cannot have zero energy. They cannot sit perfectly still. Doing so would violate uncertainty. Perfect rest would demand perfect knowledge. And that is forbidden. Even at absolute zero, atoms still jitter. Not from heat, but from quantum necessity. Zero-point motion persists. The universe refuses total silence. This changed the meaning of cold. Absolute zero is not emptiness. It is the minimum activity allowed by reality. The quietest state permitted by law. Stillness as a floor. This realization reshaped low-temperature physics. Superconductivity emerged. Superfluidity appeared. Strange collective behaviors arose. Near zero, matter behaved in alien ways. Cold did not simplify reality. It revealed new complexity. Absolute zero was not an end. It was a threshold, and crossing toward it exposed rules hidden everywhere else. This sets the stage for a deeper conflict. If motion never fully stops, what does zero actually mean? And why does the universe forbid complete rest? The answer reveals something profound about information, uncertainty, and existence itself. As temperatures approach absolute zero, behavior changes dramatically. Atoms stop acting independently. They begin to move together. Individual identity fades. Collective states take over. In superconductors, electrical resistance vanishes. Electrons pair up. They flow without loss. Energy stops leaking as heat. At first, this seems to violate entropy, but it does not. Order increases locally, while disorder spreads elsewhere. Cooling requires work. Entropy is exported. Physics keeps its balance. Superfluids reveal an even stranger effect. Liquids climb walls. They flow endlessly in loops. Viscosity disappears. Motion persists without friction. Cold unlocks new rules. These behaviors are not accidents. They emerge because thermal noise is suppressed. Quantum rules dominate. Particles obey wave-like coherence. Reality becomes synchronized. This reveals what temperature hides. Heat masks quantum behavior. Motion scrambles coherence. As heat fades, deeper rules appear. Cold is not emptiness. It is clarity. Yet even here, absolute zero remains unreachable. Each step closer requires more effort. Cooling efficiency collapses. Energy removal becomes increasingly difficult. The universe defends its minimum motion. This defense protects uncertainty. Perfect stillness would fix position and momentum. It would violate quantum limits. Information would become absolute. Reality forbids that certainty. This has deep consequences. It means information has a minimum cost. It cannot be erased without energy. Memory cannot be frozen perfectly. Every system retains motion. This connects absolute zero to computation, to memory, to time itself. Total stillness would halt change, and change defines existence. Cold reveals boundaries, not absence. Approaching zero exposes the deepest constraints on matter. It shows where physics stops us gently, but firmly. This prepares us for the core insight. Absolute zero is not a temperature. It is a boundary condition, a line reality will not cross. And understanding why tells us what the universe values most. That value is uncertainty. The universe protects it relentlessly. At absolute zero, energy reaches its minimum. But minimum does not mean zero. Particles still fluctuate. They must. Uncertainty demands it. Heisenberg's principle enforces this rule. Position and motion cannot both be fixed. Perfect stillness will require perfect knowledge. Perfect knowledge is forbidden. Reality refuses to be fully defined. This makes absolute zero a philosophical limit, not just physical. It marks where determinism fails completely. Even stripped of heat, the universe keeps options open. Motion becomes unavoidable. This residual motion is not noise. It is structure. It stabilizes matter. Without zero-point motion, atoms would collapse. Electrons would fall inward. Chemistry would cease. Cold does not remove activity. It reveals the minimum activity required for existence. Absolute zero is the quietest possible universe that can still exist at all. Anything colder would not be reality. It would be contradiction. This explains why cooling slows dramatically near zero. Removing the last energy means fighting the foundation of quantum law. Nature resists not with force, but with principle. Limits become asymptotic. This resistance shapes future technology. Quantum computers, ultra-precise clocks, low-noise sensors, all operate near this boundary. Performance improves, but perfection remains unreachable. The closer systems get to zero, the more fragile they become. Tiny disturbances matter. Observation itself introduces heat. Measurement becomes intrusion. Silence amplifies influence. This reveals a strange symmetry. Heat hides information. Cold exposes it. But total exposure would collapse uncertainty. So the universe stops us short. Absolute zero is not failure. It is protection. A safeguard against total predictability. A guarantee that reality remains flexible, alive with possibility. And that leads directly to the final realization. If perfect stillness is forbidden, then motion is fundamental. Change is unavoidable. And existence itself depends on never quite reaching zero. The climax of the story is subtle but profound. Absolute zero is not emptiness. It is the quiet as allowed state. The universe forbids perfect rest, not out of cruelty, but out of necessity. Uncertainty keeps structure alive. Motion preserves possibility. Every system carries residual energy. Every atom vibrates faintly. Every field fluctuates. Reality hums softly, even at its coldest. This changes how we see limits. Zero is not an end. It is a boundary, a reminder that physics values openness, that certainty is never complete. Absolute zero defines what cannot be done. Perfect cooling, perfect storage, perfect isolation. These remain unreachable, not due to engineering, but due to principle. This does not diminish ambition. It refines it. Working near limits reveals new phenomena: superconductivity, quantum coherence, emergent order. Cold becomes a doorway, not a wall. Understanding this reframes stillness. Silence is active. Calm contains motion. The absence of heat does not mean absence of change. The universe always stirs. Absolute zero teaches a final lesson. Existence requires imperfection, movement, uncertainty. Without them, nothing could persist. Nothing could happen. So what do you think? Are we repeating the same mistake again? The